welcome you to the lecture for section 14.2. This is MGF 1106, Liberal Arts Math, and my name is Jorge. So the objective for section 14.2 are three of them. So we're going to talk about the measures of central tendency. We're going to learn how to compute the mean, the median, and the mode of distributions. We're going to go ahead and learn how to find a five-number summary of a distribution. And then we're going to apply measures of central tendency to compare data. So the first thing that we're going to talk about is computing the mean. So let's say that a data set contains n data values, and the mean x bar of the data set then is x bars equal to the summation of x divided by n. So all that means is that we're going to take all of the data values, we're going to add them up, and then we're going to divide them by how many data values we have. So now we use the Greek letter sigma to indicate a sum. So for example, we'll write the sum of the data, the values that have 7, 2, 9, 4, and 10. So the sum of the x's then is going to be 7 plus 2 plus 9 plus 4 plus 10. Now we represent the mean of a sample of the population by using the symbol x bar. And then we're going to go ahead and use the Greek letter mu to represent the mean of a whole population. So here's an example. Company car has been studying its safety records at a factory and found that the number of accidents over the past 5 years was 25, 23, 27, 22, and 26. So we're going to go ahead and find the mean annual number of accidents for this 5-year period. So what we're going to do is we're going to add up the number of accidents and we're going to divide by 5 because we're looking at a 5-year period. So the summation of x's is going to be 25. We're going to add all the values, so 25, 23, 27, 22, and 26. And that's 123, divide that by 5. And then we get 24.6. So that means that on average there were 24.6 accidents in any given year during this 5-year period. So next thing is, let's look at water temperature. So now, water temperature at a point downstream from a plant for the last 30 days is summarized in the table. So here we have a frequency table that we learned in 14.1. So what is the mean temperature for this particular distribution? So then here's a little different. We're not just going to add the x's. So what we have here is we have a third column, and this is added to the table that contains the products of the raw scores and the frequencies. So we're going to take the x's and we're going to multiply it times the frequency. So when we have data that's categorized or put in classes, this is how you find the mean. So we'll do 52 times 4, 53 times 6, 54 times 3, and so on, all the way until we add them up, we multiply all of them, and then we add up all of those scores. So here at the bottom we can see that the summation of the product of what we call the sum of the scores, x times f, is 1,637. And then we go ahead and add up the summation of the frequencies, which is 30, and we get approximately 54.6 degrees Fahrenheit. So computing the mean of frequency distribution. So the first thing you're gonna do is you're gonna write all of the products of x and f. But before you do that, you actually have to write the column of your x's and column of the frequencies, and then you're gonna go ahead and multiply those two factors, so x times f, for each class. And then you're gonna go ahead and find the mean, which is the summation of the product, the sum of the scores, divided by the summation of the frequencies. So here's another example. Listed are the yearly earnings of some celebrities. So we have A and B. What is the mean of their earnings for the people in this list, and is this mean an accurate measure of the average earnings? So here we have 10 celebrities, and then so they're ranked in order from 1 to 10, and then we have their earnings for 2007 in millions of dollars. We have Oprah Winfrey all the way down to Angelina Jolie. So the first thing that we're going to do is we're going to go ahead and find the mean. And so summing these salaries and dividing by 10 gives us that it's $64.8 million. So remember, add up all of the x's divided by how many you have. Now for B, we have that 8 of the celebrities have earnings below the mean, whereas only 2 of them have earnings above the mean. So the mean of this example does not really give an accurate sense of what the average is for this data set, because it's influenced by higher earnings, or we call outliers. So in this case, a better measure would be what we call the median. So if we arrange the set of numbers in increasing or decreasing order, the median is the middle value in the list of numbers. Now there are two things to consider. If there's an odd number of numbers, then the median is the number in the middle position. If there's an even number, then the median is the average of the two middle numbers. So here we have a list. The table lists the ages of presidents when they assumed office between 1901 and 1993. So find the median age for this distribution. So here we have the list, and then we have the ages for each one. So the first thing that we're going to do is we're going to arrange them in order from the smallest to the largest, so 42 to 69. And there's 17 ages. So the middle age is the 9th age, which is 55. So we take the data set, we split it right in the middle, and there'll be one score by itself because it's an odd number of data points. So here's another example. 50 32-ounce quarts of particular brand of milk were purchased, and the actual volume determined. So the results of the survey are reported in the table. So what is the median for this particular distribution? So here we have, what's the median for this data set? So the number of ounces is X, the frequency is F, is X, and then F for the frequency. So in order for us to find this, we're going to have to go ahead and use the, to find the median, we're going to have to list them, if you will, from the smallest to the largest, and then find what the median is. So now, because the 50 scores are in increasing order, the two middle scores are in the positions of 25 and 26. Now we see that 29 ounces is in position 25, 30 ounces is in position 26. So the median for this distribution is 29 plus 30 divided by 2, which is 29.5. The next thing is what we call the 5-number summary. So the 5-number summary essentially divides the data set into different parts, if you will. So we have the lower half, or the minimum, and then we have the max. Then we have the first quartile, we have the third quartile, and then we have the median. So minimum value, Q1, median. The median is also known as Q2, Q3, then the maximum value. So here's an example. Consider a list of ages of the presidents from the previous example. So we're going to go ahead and find the following. We're going to go ahead and find the lower and upper halves, the first and third quartile, and the 5-number summary. So the first thing is we're going to go ahead and find the median, which is, again, is the Q2. And then we can identify the lower and upper half. So here's the median, 55. The lower half is this data set here, and the upper half is this data set. Now the median of the lower half is your first quartile, which is 51 plus 51 divided by 2, which is 51. And the median of the upper half is Q3, is going to be 60 plus 61 divided by 2, which is 60.5. So the 5-number summary is the following. 42 is the min, 69 is the max, Q1 is 51, Q2 is 60.5, and the median is 55. So we're going to represent the 5-number summary by using what we call a box and whisker plot. So box and whiskers, here's the minimum, here's the maximum. So the easiest way to do this is to draw a horizontal line, a vertical line right at the median, Q1, median, Q3, and the max. And then what you do is you draw a box around Q1 through Q3, and then you connect the minimum to the box, and then the box to the maximum. Next thing we're going to talk about is the mode. Now the mode of a set of data is the item that occurs most frequently. So if two items occur most frequently, then each is a mode. If more than two scores occur, then we say that there is no mode. So it can be bimodal if two scores are the mode. So here's an example. Find the mode for each data set. So for A, the mode is 5 because it occurs the most often. For B, there are two modes. So this is bimodal, since we have 3 occurs 3 times and 9 occurs 3 times. For C, as you can see, there is no mode, and for D, again, there is no mode. Now, assume that you're negotiating a contract for your union. You have gathered annual wage data and found that 3 workers earn $30,000, 5 workers earn $32,000, 3 workers earn $44,000, and 1 worker earns $50,000. So when you're negotiating, which measure of central tendency should you use? The mean, the median, or the mode? Oops. Okay, so here we have the mode, that's 32,000. It's the number that occurs the most often. The median is, again, 32,000. And then the mean turns out to be 36,000. So now, to make the salaries appear as low as possible, you want to use the mode of the median, because if you use the mean, it shows that you make more money on average. And that's the end of section 14.2. Thank you.